first step, okay, look at here. This is R1, R2, and R3. Okay, so I'm applying the transformation R2 tends to simple. This you can make this 2 0 very easy. So R2 minus R1. So 2 minus 2, the second element becomes 0. Fine. Next 3 will be there. 3 will be there. We can make them this 3 0 by using this 2. So how much we can multiply here? Multiply with 2 here. Multiply with here 3 here. See here, 3 2 is a 6 minus 2 3 is a 6. So how much we can multiply to R3? So R3 tends to, we can multiply with 2. 2 R3 minus 3 R1. Is it clear? Multiply 2 here, multiply 3 will be here. But can you do directly here? What we have to do? What is the first step after taking the given matrix as capital E? Yes. If we apply that row operation, how to write?
A is equal to IA.
A is equal to I into A. Without that, you cannot. Okay. So this is clearly you have to write. So this is clearly equal to I into A. I into A. So that is identity matrix. You can write here 1 0 0 0 1 0 0 0 1 into A. So whatever the transformation you are applying on LHS, the same operations you can apply on identity in RHS. Okay, so here the LHS becomes, see, in both the transformation R1 is remains same. I'm applying on R2 and R3. Okay, R1 remains same. So 2 minus 3 3 here 1 0 0 is same. Now R2 R3 will be changed. Immediately can write these two values are 0. Yes or no? R2 minus R1. To make these two elements 0 only, we apply this transformation. So okay, 0 0. Whatever this R2 minus R1 5, R2 minus R1 0. Okay, then same row operation apply here. R2 minus R1 minus 1, 1 minus 0 1, and 0 minus 0 0. Fine. Next, 2 R3 multiply here 2, multiply here 2, multiply 3 3. Right? So 2 into minus 2 minus 4, minus 4 minus into minus plus, already minus is there, minus into minus plus, 3 into 3 9 plus 9, so minus 4 plus 9, it will be 5. Is it clear? Then 2 to the 4 minus 3 into 3 9 minus 9, so that is what, 4 minus 9 minus 5. Is it right? Next, in the same way, RHS also same, 2 or 3. Multiply here 2, 2, 2, 3, 3, 3. So 2R2 minus 3R1. 2R3 minus 3R1. Nothing but here 0 minus 3 minus 3. And 2 into 0, 0. Clear it is 0. And 2 into 1, 2 minus 0. That is 2. Is it that? Is it right? Okay. Fine. Now, is it a identity matrix? So LHS, we can make them to identity. It is not. First, we can find the diagonal matrix. Remember that we can make them LHS into diagonal matrix. Then after, we can easily make the LHS to identity. Okay, very easy. Now what to do? We can use this element. Then we can make them remaining to our 0. Okay, we can easily make this R3 element 0. So R3 minus R2, R3 minus R2, this element becomes 0. But how can you make this minus 3 0? So minus 3 is belongs to R1. R1 tends to, how much we can multiply here? Multiply 5 here, multiply 3 here. So 5 into R1 plus opposite signs are there. Whenever it is opposite signs, so just keep it here plus. So then 3 into R2, 5. Next, R3 tends to R3. Simple. R3 minus R2. R3 minus R2. So these two elements become 0. I said very clearly, use this first element, you can make them remaining two element 0. Use this second element, like we can make them remaining 2 0. At last, we can use this last element, you can make them these two are 0. Only 3 steps. Okay, so then clearly, then given matrix, what about the matrix here? I am here only, I'll write here. So fine, this is equal to 3 by 3 into A. So here, what is the row remains same? Can't be changed. Second row. Here we are applying on R1 and R3. R2 is fixed, that is 0, 5, 0. Here also R2 is minus 1, 1, 0. And what about these two elements? These two elements you can write directly 0, 0 because to making these two elements 0 only we applied these two transformation. Immediately can write these two are zeros. Now coming to R1. 5R1 plus 3R2. 5 into 2, 10. Plus 3 into 0, 0. So just 10 here. 10. Next here. 5 into R1. 5 3s are 15. 15 plus 3R2, 0. So here it is 15. So the same operation apply on RHS. 5R1, 5. 5R1 plus 3R2. 5 minus 3, that is 2. Then here 5R1, 5R1, 5 into 0, 0 plus 3R2 means 3 into 1, 3. Next 5R1, so both will be 0 here. This is 0, clear. Next, what about here? R3 minus R2. R3 minus R3 minus R2. Right. 5 minus 5 already we written. R2 minus R3 minus R2 minus 5 minus 0, minus 5. Fine. What about here? Here also same R3 minus R2 minus 2. R2 minus minus 1, 2. Is that clear? Yes. Yes. After that, see here, we applied two operation. First, I used this element. I make this two R0. Then after I use this diagonal, second diagonal element, I make them the corresponding elements are 0. Then finally, I want to use the last diagonal element. I want to make them these two are 0. These two are 0. Okay, this minus 5 you can use. You can make already one element is 0. Okay, just you can make this 15 to 0. For that already minus 5. Okay, use R3. You can make them R1, R2. The corresponding elements are 0. For that, what is the operation we can apply here? Yeah, I'm writing the operations here. So simple, only one operation. R1 tends to uh, R1 plus 3R3. Is it clear? Is it clear? First step, I'm using R1, first row, I'm making. Next, I'm using R2. Okay. Next, I'm using R3. R1, R2, R3. That's it. Okay. Then that is enough because already one element is 0. Okay, fine. Apply this. You can write remaining two are same. R2 and R3 will be same. R1 only will be changed. Next, write R2, R3 as it is. What is R2? 0, 5, 0. 0, 5, 0, 0, 0, minus 5. Here also the second row minus 1, 0. And minus 2, minus 1, 2. Okay. Then what about R1? So R1 plus 3R3. R1 plus 3R3. 10 into this is 10 alone. Then R1 plus 0 plus 0, that is 0. Then finally, see this is clearly 0. 15 plus 3 into minus 5, 15 minus 15, 0. Then same here, R1 plus 3R3. R1 plus 3R3. So 2, minus 6 minus 4, then R1 plus 3R3. So this is 0, and this is R1 plus 3R3, 6. Right, finally we got a diagonal matrix. Is this diagonal or not? First we can find the diagonal. After that, what to do? Just we can make them to identity form by R1 dividing with 10, R2 dividing with 5, R3 dividing with minus 5. Okay, so apply R1 tends to R1 by 10, R2 tends to R2 by 5, R3 tends to R3 by minus 5, right? So finally, left side is 1 0 0 0 1 0 0 0 1. We got identity. Right side is becomes, yeah, anyone. What about the first one? Yes. So when I dividing with 10, here minus 4 by 10 means minus 2 by 5. 0 by 6 by 10, 3 by 5. Anyhow, R2 dividing with 5. So here also 5. So 1 by 5, 1 by 5, 1 by 5 is common all three rows. If I write like this 1 by 5 outside, shall I write like this? So here it is when you're dividing with 2, that is minus 2, 0, 3. Yeah, R2 dividing with plus 5. So right, R2 1, 0. And but R3 dividing with minus 5. Okay, minus to minus plus 2, 1 minus 2, because I multiply with minus. I'm taking 1 by 5 outside. If you want, you can divide R1 with 10, R2 with 5, R3 with minus 5. After that, you can take 1 by 5 outside, even though we'll get same. So finally it is in the form of BA. So I is equal to BA. What is B? Where B is equal to 1 by 5 times of minus 203. Otherwise, you can multiply. So minus 2 by 5, 0, 3 by 5, minus 1 by 5, 1 by 5, 0, 2 by 5, 1 by 5, minus 2 by 5. Like that also you can write. So this is the required inverse of the matrix capital A by using elementary operations. Okay. Okay, till now we applied that row operations. We got like this. Can you shall we can apply now column operations? Let us see one more problem. So by using column operation, how can we find the inverse of given matrix? Yeah, note it down fast. Yeah, completed. Yeah, next choose any question, will apply the column operations. Yes, anyone? Choose any 3 by 3. Will apply the column transformation.
So 17.
Question number
17.
17. Okay, right. The question number 17 is, let us take given matrix as capital A, uh, 2 0 minus 1, and the second one 5 1 0, and the third one is 0 1 3. Right. Here also same, using the diagonal elements. Okay, using the diagonal elements, then we can use the column transformations, then find the inverse of a matrix. So if you want to apply the column transformation, you can write A is equal to A into I, not I into A. Identity matrix must be right side of A. Okay, fine. Substitute here A value, A matrix is equal to A into identity matrix. So here given matrix of order 3 by 3. So identity also must be 3 by 3. Right. 2, 0, minus 1, 5, 1, 0, 0, 1, 3. Clear? 510 013. Now I want to use the first element. I want to make remaining column wise C1, C2, C3. Same. First you can use C1. You can make them the corresponding elements are 0. Next you can use the C2. You can make the corresponding elements are 0. Next you can use C3. You can make these two elements are 0. So here already C2, the corresponding element of C2 is 0. So just we can make them this value is 0. So C3 tends to using C1. 2C3 plus C1, is it okay? Multiply 2 here, minus 2 plus 2. Minus 2 plus 2 becomes, this element is 0. So immediately here also, you should write the, other than this C3, you can write C1, C2 first. Then after you can simplify this C3. So what is C1? 2, 5, 0. C2, 0, 1, 1. Remains same. Here also C1, C2 same. 1, 0, 0 and 0, 1, 0. Fine. So what about C3? C3, this element directly 0. So to make them this minus 1 only, we apply this operation just to find two values alone. So 0 means 2 into 0, 0 plus 5, right. Next, 2C3, 2 into 3, 6, 6 plus 0, 6. The same operation you can apply here. C2, C3, 2 into 0, 0 plus C1, 1. And 2 into 0, 0, 0. And 2 into C3, 2 into 1, 2 plus, okay, 2 into A. Clear? Then, uh, fine, I used this C1, I make them, the corresponding elements are 0. Next, to use the other diagonal elements, which is belongs to C2. This is C1, C2, C3. Here also C1, C2, C3. Right. So use one, you can make them remaining two elements are 0. So one is belongs to C2. So C1 is 5. So C1 tends to C1 minus 5C2. C1 minus 5C2. Is it clear? C1 tends to C1 minus 5C2. Then the element becomes 0. In the same way, C2 tends C2 or C3. One is belongs to C2. You can make them this. So C3 tends to C3 minus 5C2. I'm using next case C2. Here I'm using C1. And now I want to use C2. Next, I want to use C3. Okay. Now the given matrices becomes A into what is remains same. I'm applying the transformation and C1, C3. C1, C3 will be changed. C2 as it is, right? C2 is here. 0, 1, 0, 1, 1. Here 0, 1, 0. Okay. Now, immediately you should write these two values are 0. To make them these two values 0 only, we apply the transformation. Just to find four values alone. Fine. Next, C1 value. So what is C1 minus 5C2? C1 minus 5C2. C1 is 2 minus 5 into 0. So this is 2. Next, C1 minus 5C2. C1 minus 5C2 means, uh, what about this? Shall I write minus 5? 0 minus 5 into 1 minus 5. Next, let's find two values. C3. C3 minus 5C2. So this is clearly 0. And C3 6 minus 5 into 1. 6 minus 5, 1. Is it clear? The same operation you can apply here. Then C3 minus 5C2. Sorry, C1 minus 5C2. C1, 1 minus 1. Here 0 minus 5 minus 5. Here 0, both will be 0, 0. Next, C3 minus 5C2. C3 minus 5C2, 1. C3 minus 5C2 minus 5. C3 minus 5C2, 2. So I'm doing very slow, but you should write very fast. Okay. Now, is it identity? Is it diagonal? No, it is not a diagonal. So I used C1. Next, I used C2. I want to use C3. So C1, C2, C3. I want to use this one. I want to make them remaining values are 0. So C1 tends to C1. C1 is minus 5 already. How much we can multiply here? And opposite side, opposite here, minus here plus. So plus 5 times of C3. Next C2 tends to C2. C2 is very easy to make C2 minus C3, right? 1 minus 1, 0. So what is the remain, what is the column is same? C1, C2 are changing. C3 will be same. So 0, 0, 1. Here C3, 1, minus 5, 2. Yeah, C1. C1 becomes, so immediately you should write here 2 or zeros. To make these two values 0 only, we apply this. So just to find the four values. Okay, now C1 plus 5C3, 2. C1 plus 5C3, 0. Next, C2 minus C3, C2 minus C3, 0. C2 minus C3, 1. Okay, we got. Next, here, C1 plus 5C3, C1 plus 5C3, 5C3, 6. C1 plus 5C3. Is it minus 30? Is it right? I got
Yes,
like
sir.
this. 5C3 minus 10. C1 minus 5C3. Sorry, plus. Next, C2 minus C3, easy. C2 minus C3 minus 1. C2 minus C3, 6. C2 minus C3 minus 2. Okay, now finally we got a diagonal. After getting diagonal, we know very well how to make the identity. See, already two elements are unity, one. So you can make them this two value one. What to do? C1, C1 only. C1 tends to C1 by 2. C1 by 2. Column wise, you can apply column only. So first column dividing with 2, entire first column. So when I dividing with 2, so C1 tends to C1 by 2. So first, so remaining first, I'm applying the transformation on where C1, C2, C3 will be changed. Same 1, 0, 0, 0, 1. Here also minus 1, 6, minus 2, 1, minus 5, 2 into that's it. Then what about here? 1, 0, 0. You're dividing with 2, 3, minus 15, 5. See, so this is in the form of left side is identity, right side is A into this is in the form of B. So this is the inverse of given matrix A. Product of any two matrix becomes identity. So the two matrices are inverse to each other, right? Therefore, the required inverse of given matrix is uh, 3 minus 1, 1 minus 15, 6 minus 5, 5 minus 2, 2. Like that you can write. So in this way, we can find the inverse of a matrix by using transformation. Anyhow, this was a deleted portion last year. Having any doubts, you can ask.
Sir,
Yes.
sir, in row operations, sir,
Okay.
some sums they're changing the row around, sir. R1 tends to R2. How to find which sum we want to change the row, interchange the row, sir?
Your voice is not clear. Once again, can you repeat?
Sir, how to find in which sum we want to interchange the row, sir? R1 tends to R2, like that, sir.
It's depending on the value. It's depending on the value, and also only remember either it is row operation or column operation. So we need to use the diagonal elements. Row and column, we should use, simply remember that, use diagonal elements. So based on the values, you can apply, multiply, divide. Okay, like that you can apply. So first, only the thing is use the diagonal. First, use this diagonal. If you want to apply row operations, use these two. You can make them remaining 2 0. So here 5 is there, here 2 is there. For example, two different values. There is no common factor. So 2 is prime number, 5 is a prime number. Multiply 5 here, multiply 2 here. After that, so R2 tends to, for example, if you use R2, R2 tends to 2 R2 minus 5 R1. So use first this, you can make them these two are 0 if you apply row operation. Otherwise, you can make them these two are 0 by applying column operation. In exam, they don't mention anything, just simply they'll mention using the transformations. Okay, so either you can use row or column. If they ask particularly, you can apply, go through that particular operation.
Okay, sir.
So this was deleted. I told this was deleted. I think so. This year also, if online classes are going on like that, they might be again delete. Okay. Anyhow, you have to practice it. Next period is OBT class 12:20 to 1. We will discuss OBT. Yeah. In matrices, have you got any doubts? If you have any doubts, you can ask. So complete your work. Okay. You can complete your classwork. You can maintain the classwork. That is very, very useful to you for board exam.